So in this video, we're going to talk about different types of memory. So from the specification, you need to know that there are different types of memory within a computer. We've got RAM, ROM, cache memory, and register. So what I'm going to do in this video is explain the different types and what they do and why we use them. So first one, let's talk about RAM, okay? So RAM stands for Random Access Memory. Okay, and actually, before I even go into this detail of this one, I want to just draw you a little diagram and explain the whole process of how the fetch and execute cycle works, because I think this is a better way to explain the general process. So how computers work, you have something called the CPU. CPU looks something like this here. There's your CPU. And then over here somewhere, and obviously this isn't to scale or anything, but we have RAM, okay? Now RAM is imagine it like a queue system. So what you've got there is you've got some numbers like 1, 2, 3, and so on, and inside there you have some binary numbers as well. So what happens is the CPU is connected to RAM via something called an address bus. And then they also have a bidirectional bus going the other way called a data bus. Okay. Now how the process works is the first instruction that needs to be fetched from RAM. Okay, so the CPU will go, right, I need to fetch the instruction number 1. So that gets sent along the address bus up to RAM, and it goes, right, where is position number 1? Well, that's here. What binary is in position number 1? It's this instruction here. That data gets sent back along this data bus, so from RAM to the CPU, and then inside here it does something with it. So it will decode it, execute it, and then the process starts again. So this goes up to number 2, it finds position number 2, and so on, and that just loops back and forth. Okay, and that's generally how the fetch execute cycle works. So now that we understand that, we can understand a little bit better about what ROM actually is, what RAM is. So what RAM is, RAM basically contains the instructions / data that the CPU will execute. Okay, and what I mean is every time you do something on a computer, you try and load a file, you try and you type on the keyboard, you open a web page. All of those different things are instructions that it needs to go into RAM and queued up in this like queue process until the CPU takes it and executes it. So they've got to wait their turn, and the CPU will work very quickly using something called scheduling to choose each of those one at a time, stick it back into the CPU, and then decode it and do what you want it to do. To us as humans, that all happens very quickly, but to on the computer, there's a lot of things going on in the background. So RAM is basically there to hold all of these instructions that you've asked the computer to do, or some of them are just operations that happen in the background. We don't ask them to happen, but they're going on. And then when it's done, it's wiped from RAM, and the process carries on. So this contains instructions data that the CPU executes. RAM is known as volatile memory, which basically means that when the computer loses power, RAM is wiped. Okay, so as soon as you turn off your computer, that is gone. Everything, all the contents of RAM is wiped, and basically when you turn it back on, then it will start all over again. So the first things that will go into RAM when you load it up is instructions for your operating system, like Windows or iOS. And it will start to populate that, and it will start to do that kind of stuff and load up your computer. So RAM is volatile. It doesn't keep it. It's temporary, and it will run out. You can run out of RAM if you don't have enough, because you can't hold too many instructions. Okay, so that's RAM basically. It contains all the data and instructions that you want to execute while you're using the computer. And as soon as you turn it off or it loses power, then that RAM is wiped and the process starts all over again. Okay, RAM is also upgradable, as I mentioned before, so you can put more RAM in a computer if you wish. Certain devices you can't, like phones, for example, but like a desktop PC or even a laptop to an extent, you can put more RAM in there to help it do more stuff. Okay, so that's the purpose of RAM. The next one we're going to talk about is ROM. Now, ROM is read-only memory. Okay, so read-only memory. And how ROM works, ROM is a chip that is preloaded, okay? So it's preloaded with certain instructions, okay? So ROM is preloaded with startup instructions. So when you first turn up your computer and you turn it on from having no power, the computer doesn't know what to do. The CPU starts up and it goes, right, I don't know what I'm doing here. I just know I'm existing. And RAM will be empty. It doesn't know what it's doing there. So what happens is it goes to ROM first, and the CPU will check ROM, and ROM will say, right, we need to load up Windows, or we need to load up Android. So it goes, okay. So it goes, I need to get those instructions from the hard drive where, say, where Windows is stored, and then it will start to put the startup instructions into RAM. So the only point of ROM is to, in a desktop PC anyway, or a major computer, is to store preloaded instructions. So they're all stored in ROM, and that's all it does. It's also known as BIOS, system BIOS. That's also stored in there as well, okay? So that stores all that. ROM is non-volatile, okay? So ROM is RIM, it's not RIM, it's ROM, is non-volatile, which means that when there is no power, ROM still exists, I guess, or still contains the data it should. So that data is not lost, okay? So when you turn the power off, ROM is not wiped, that data is still there because we need to know those startup instructions. We need to know where to find Windows or iOS or Android. So if we turn it off and turn it back on and it can't find it, we're going to have a bit of a problem. So ROM is non-volatile, and it's also ROM is not upgradable and cannot be overwritten. Okay, so for most users of a computer system, they will not be able to access ROM or change it or alter it, and you can't upgrade it. You're given a certain amount of ROM in your PC, and that's all you need to use. Okay, you don't need to add anything to it. Obviously, in the reality, you can overwrite ROM if you really want to, but for most users, they won't touch it. They won't go anywhere near it. It's just the startup instructions. So that's ROM. So we ticked off those first two. We've done RAM and we've done ROM. Next one is cache memory, and I don't know why I've crossed it out. I meant to circle it. So let's look at cache memory. Okay, so let me draw you another lovely picture again. So here is my CPU. Let's make it a little bit bigger now. There's my CPU. Okay, and we already talked RAM was over here somewhere. Let's put RAM over here. There's RAM. I'm not going to make it as detailed this time. There's RAM. And there I've connected up. So I mentioned before that every time you want to fetch an instruction, it has to go from here to here and then back to here, and that process repeats itself again and again and again. Now, what often happens in computers is we use the same instructions multiple times. So we go into the same common instructions and we keep going back to them. Now, CPU and RAM are separated by a distance. They're not that far away, but there's still a delay between the instruction getting from CPU to RAM and then back to the CPU. So what cache memory is, there's three different levels of cache. There's level 1, level 2, and level 3. And cache is basically either a chip that's either on the processor or off the or very geographically close to the processor, and that is our cache memory. Okay, let's say that'll be like level 1 cache, and that'll probably be like level 3 cache. Okay, and the closer it is to the processor, the more efficient it is, but obviously they're smaller in size. So you can have bigger cache a little bit further away. The whole point of cache is to basically store common instructions. So let's say the CPU is like going to get this one and back again and this one and back again. It goes, hang on a minute, I keep fetching the same instruction. Why am I keep going back into to get it? Why don't I stick that inside my level 1 cache here? So therefore, I don't need to go all the way over to here to get it. I can simply just go to here and get it instead and pull it out of level 1 cache. So cache memory is super fast RAM found geographically close to the CPU. Okay, so it's found geographically close. It's pretty much on the chipset or close to the chipset. It contains regular use instructions regular instructions to speed up the process. So it makes things faster, basically. It doesn't have to go as far to get it. Therefore, there's less of a time delay. Therefore, it saves you time in the long run. Okay, so it's just more efficient. Like RAM as well, it's also wiped every time you turn off the computer. So when you turn it back on, it kind of resets itself. That's cache memory, close to the CPU or on the CPU. Super fast RAM, which contains regularly used instructions. And the last one is register. So a register is going back to our CPU. So we'll go to this diagram. During the fetch execute cycle, there's actually lots of these little registers which are found on the chipset itself. Okay, you don't need to know these for the GCSE, but we've got PC, which is the program counter. We've got memory address register. We've got memory buffer register. We've got CIR for current instruction register. Okay, now what these registers do, they're little bits of memory that hold specific instructions during the fetch execute cycle. So as it works its way through the fetch execute cycle, these different registers are used for different purposes. For the GCSE, you don't need to go into much more detail about what they actually do on that level, but you just need to know what registers are. So a register is a memory location within the CPU used during the fetch execute cycle. Each register has a specific purpose and allows the CPU to fetch, decode, and execute instructions effectively. There you go. That's really all you need to know about a register. Okay, it's a specific memory location or specific piece of memory located on the CPU, which is used during the fetch execute cycle to store different bits of data. So what happens, just to give you some context, the memory address register contains the next instruction to be executed. That goes to RAM. RAM brings back the instruction. That gets stored in the memory address register, which then puts it to CIR to split it into different things. So I'm not going into more detail. You don't need to know that. But you just need to know that it's a memory location within the CPU used during the fetch execute cycle to store specific amounts of data. And also they are written over. So as the fetch execute cycle happens, each of these registers will get overwritten with a new bit of data. And they're also wiped when the CPU is turned off, and then it starts all over again when the power is resumed. And there we go, everybody. So that is different types of memory.